Thank all of you for joining us at this unholy hour. This is the earliest I've been up in 6 years. It is, frankly, the only reason I am up at this hour is because I just flew in from the East Coast last night and I'm still on East Coast time. To get into it, the presentation is up at this link right now. You can pull it down if you wish. The couple times I've done this, I've had some pretty good success in terms of bringing down the wireless network, so we may or may not have enough room in the people or enough people in the room to do that. But redmonk.com/public/lucene.pdf. So feel free to bring it down. Anyhow, what I'm here today to talk about really is data, obviously big data, and more specifically its role with respect to search. To do that, what I wanted to do was basically just to provide a little bit of context, because the world of persistence and the world of data has changed dramatically over the course of the last, say, basically about 24 months. So in the beginning we had the database. These are the respective founding dates for these particular databases. Do we have any Ingress people in the room? Okay, good, because they're not going to be pissed at me. Ingress preceded these databases. The founding of Ingress dates back to about 1974. The concept behind the relational database actually dates back to the late 60s, and some of the work that some of the folks from IBM research were doing. But the commercialization of these databases occurred a little more than 30 years ago, back around 1979, obviously followed closely by IBM with DB2 and Microsoft with SQL Server. Those of you with some history in the room will probably recognize that SQL Server itself was actually an OEM product at first rather than something written by Microsoft. That's changed. But anyhow, the point here is that for the better part of 30 years, we've had relational databases as the primary mechanism to persist data. And as the saying goes, when you have a hammer and so on, everything tends to look just like this. This is one of the biggest challenges our industry faced over the past, say, decade at least. In the early days when a lot of the web firms came along, they tried to build out infrastructure, and they tried to build out infrastructure in the way that we had been building infrastructure for the 20 years before that, meaning operating system, relational database, web server, and so on. And, in many cases, that's a perfectly fine model. MySQL obviously powers, a large part of the web world still today, although that is changing. And, the relational model works pretty frequently. The challenge is that it doesn't work all the time. And, this was, really the problem, right? In our industry, basically the answer was a relational database. Now what's the question? Now that doesn't make a lot of sense to me. It probably doesn't make a lot of sense to many of you. And it certainly didn't make a lot of sense to Adam Bosworth. How many of you in the room know who Adam Bosworth is? Okay, just a couple. Adam, for those of you who don't know him, has a pretty long pedigree in the industry. He was on the original Microsoft Office team, left and did some pretty important work at Google. And more importantly for our discussion here today is somebody who has a very interesting perspective on the industry. And what he said back on December 29th, 2004, was basically that, databases fundamentally have a problem. And he cited a number of problems with this model. Among them, the inability to effectively partition, right? And this is, something that a lot of people in the room, who are familiar with, sort of the scale-out web model, probably understand intrinsically well. How do you partition data across a large cluster? Well, it turns out, with traditional relational databases, it wasn't all that easy to do. And more importantly, the flexible schema. The question of, what is my data structure? Anybody in the room who's had relational database training will tell you that one of the first things you do is determine the structure of your data. That's just, I went through a couple of different courses myself, coming up. And that was, effectively how you proceeded. Well, what you found is that this didn't always make sense. In certain cases, sure, it's fine. In other words, if you are building an order flow system and you happen to know how your orders are structured, fantastic. Establish the schema, proceed with the database, and you're probably going to be good to go. But in a world where we don't always know exactly what the structure is going to be up front, or that structure may change very, very frequently, or in some cases it may lack structure entirely, It's not the best model in the world. So what this led to was what we at Redmonk call the Cambrian non-relational explosion. You guys probably have heard this referred to as the NoSQL trend. I personally don't like the NoSQL term, not least because many of these NoSQL stores are furiously adding back SQL features at the present time. But also because it lumps into the same bucket a bunch of tools that don't really have anything to do with one another. So we at Redmonk, we watch a lot of trends, and we watch data incoming to our web properties as one example. And we regularly get queries that will consist of things that say Solr, Neo4j, MongoDB, Couch, compared. Well, those data stores don't really have anything to do with each other, right? They're completely different types of data stores. Now, you can make them work in conjunction with one another, but at the end of the day, they're not terribly comparable. So, what's happened is this, and this is a chart of the Cambrian explosion that we refer to. About 530 million years ago, we had an explosion, an absolute explosion of evolution. And Darwin himself actually cited this as one of the major problems with his theory of evolution. Because the theory of evolution depends on a set of sort of reasonable evolutionary steps that occur over time. And back in the Cambrian period, this model is contradictory. We had an absolute explosion. Obviously, this is an eye chart that you probably can't read. And frankly, I probably couldn't read it to you because I don't know all the species involved. But the point is that we came from a very narrow bottleneck of the total species on the planet, and this exploded. And exploded in a very brief period, geologically speaking, to basically all of the phylum and categories that we have today. And what we see is basically the same thing at work right now in the data space. So we've gone from the period that I was referring to earlier, which is, as I said, described as, the answer was a relational database. Now, what's the question? Now we've gone to pretty much the inverse. There is a there's a persistence mechanism, rather, for pretty much anything that you want to do. The question is why? Why has this happened? Well, the answer from our perspective is simple. It's different tools for different jobs. Or I should say different data. Because as it turns out, if I'm storing documents, I may actually want a persistence mechanism that knows how to store documents. If I'm storing just a key and a value, I may want a store that just stores a key and a value. If I'm storing large volumes of unstructured data, I may prefer to use a distributed file system, and so on. We basically have gotten to the mechanism, or we've gotten to the point where we have different mechanisms to attack different data types. And the thing is that as I sit here telling you this, it seems really dumb, right? It seems like we should have had this for a long time. I mean, how hard is it to basically say, yeah, okay, we're going to have a different persistence mechanism based on what we're storing. But this just was not the reality. And this, fortunately, in our opinion, has changed, and changed dramatically in the past 24 months. So, part of the problem here, and part of the incentive and part of the driver, was not just these different data types. Because frankly, if it was just the different data types, unfortunately, I think we would probably be stuck in a world with just relational databases. Because to give technologists credit, for the 30 years or 30 plus years that the relational database dominated the market, developers just like many of you in the room, got really creative in bending a relational database into tasks and workloads it was never intended to service, ever. So, on the one hand, that's to the developers' credit. But what happened, really as the web grew up, was that we began generating a lot of data. Data volumes that really previously we either hadn't seen before, or maybe a couple of entities on the planet had ever seen before. So this presented entirely new problems, because while you can bend a relational database to challenges like search, it's very difficult to do that at the types of scale that we were talking about. This is basically nothing more than a Wolfram. If you go to Wolfram Alpha, this is just an exponential plot. I'm sure many of you have seen graphs from analyst firms, research entities, universities, colleges, and so on, which are predicting all sorts of dire things like we're going to generate more information in the next year than has been generated in all human history. And all sorts of these huge, grandiose predictions. The problem is that they're pretty well true, all of them. This is not anticipated, right? This is the kind of growth trajectory that we are all on. They had an article in the New York Times a couple of years ago, about 2 years ago now, in fact. They basically said that the human, on average, consumes between 27 and 32 gigabytes of data a day. That's a person. So think about what a business is going to generate. When a business is intending to service thousands, tens of thousands, hundreds of thousands, or millions of customers, right? We have a pretty fundamental data problem. Because when we have all of this data, it presents challenges. And this is why a lot of the attention goes to big data. And a lot of attention goes to the data volume and the data size and the data scale, which is as it should be. These are impressive achievements. When we have, as we do today, tools available in open source form that can store, attack, and retrieve information from petabytes of data, from legitimately petabyte stores of data, that's impressive. And that's something that we fundamentally haven't seen before. These tools used to be restricted to very, very high-end commercial alternatives. So the fact that that's changed is a good thing. But the fact is that when we talk about true scale, when we talk about petabyte level big data, not many people have that, right? There's really a handful of firms on the planet that are dealing with legitimately petabytes of data. At Redmonk, we deal with what we consider sizable volumes of data. We're combing and we're mining data to gain insight. We'll cover that in just a little bit from a search perspective. But you know what? At the end of the day, the data sets we're talking about just aren't that big, right? So one of the data sets we look at is Hacker News. So we've accessed, how many of you in the room have seen Hacker News? Okay, good show of hands. Hacker News, for those who haven't seen it, essentially is a developer forum, a developer site where people link on stories and research papers of the day. So we have access to this data set. I think the latest one is 2.2 million posts, I believe, with all the associated comments. Guess how big that data set is? Anybody? No guesses. 50? That's a good guess. 5? 5's closer. It's under 5. It's about 4.2. All right. So the point here is that there's actually a lot of data contained, in that data set. Quite a lot. There's much to be mined, much to be extracted from it. It's just not that big. So it's great that we have tools for big data. Many of you in the room and many of the speakers that you will hear at this conference have truly big data problems, hundreds of terabytes at least. But the fact is that even attacking databytes under 5 gigs, the 4.2 gigabyte, can be a challenge because we're talking about unstructured data. Now, I'm on a panel at the end of the day with a number of different folks, folks from The Guardian, folks from Lucid Imagination, folks from Postgres. I highly recommend you attend just because I think it'll be an interesting talk. But when we were talking about it beforehand, a couple of the guys were going back and forth about what unstructured data is. And it's true. Most data tends to have structure, some structure. English prose, for example, tends to have sentence structure, if nothing else. But at the end of the day, when while we can argue over what is unstructured versus what is structured, and whether there truly is unstructured data, the fact is that loading an English sentence, in spite of the fact that it does have some structure to it, loading that into a database, is not particularly realistic. This is another form of unstructured data. Anybody recognize this? Anybody know what this is? There you go. It's an Apache log. So this is just one of our Apache logs. I think the top 50 lines of our Apache log. So this clearly has structure, right? We have space-separated values. We have timestamps. We definitely have some form and function to this. At the same time, loading this into a relational database is a pain. It's a non-trivial endeavor. And then certainly retrieving things from it is also non-trivial. Whereas with search, with other tools, I don't need to load it anywhere. I can act on it sort of as is, which is an important distinction, which we'll get to. So anyhow, between the size and the lack of structure, it really is amazing anything gets found. It's kind of like the proverbial needle in one of these guys. But worse than that, it's hard to ask the right question. If there's one thing, just one thing, that all of you take away from this talk, I hope it's this. This is, an insight that I gleaned from Kevin Wheel from Twitter. Do we have anybody from Twitter in the room? I know we have some Twitter speakers later. Anyhow, so Kevin Wheel heads the analytics department at Twitter. And one of the things that he talks about is the fact that it's very, very hard to ask the right question. And the way that we talk about this, with clients and prospects and just developers like yourself, is this. If I gave you, any of you in the room, unfettered, unrestricted, uncensored access to the Google index tomorrow, what would you ask? Right? Where would you start? Google's index is good enough that they can predict the flu better than the CDC can. If you go to Google Flu Trends, you can check it out for yourselves. So they can watch search patterns, just across their repository, across their index, and extract meaningful insights from that. The challenge is knowing what to ask. This is a fundamentally hard problem to solve because it is intrinsically non-technical. We have the tools to ask and answer very interesting questions. But honestly, a lot of it still comes down to people. What do we want to ask? Now, there are hints of where this is going. Have any of you seen Google Correlate? It launched, I believe, yesterday. If you haven't seen Google Correlate, I suggest you check it out. You basically can look at what searches correlate with your keyword, what searches correlate with your particular data. And some of the results, frankly, are not terribly insightful. The number one correlation for NoSQL, for example, is something like must, raku, todo, some nonsense string. So the data is not perfect, but this is a hint of where we're going. When I might not know what I need to compare, when I might not know what I need to ask, these tools and tools like it are going to help me ask that question. But as you go forward, and when you go home and when you think about your search initiatives, this is the fundamental question you need to think about. And it's important because you may only get one chance. One of the things that we tell people regarding search is that the most important answer you can deliver is the next question. And this is important for two reasons. First of all, most searches aren't going to turn up what somebody wants immediately. At scale, sure, if you're looking for a discrete product or link, you might turn something up. But generally speaking, if you're researching anything of any complexity, it's going to require multiple searches. So that next question is hugely important. But particularly for those of you in the room, who are designing search applications for your business, search applications for your employees, search applications for developers or researchers. Getting them to ask the next question is crucial, because what happens, and I think we all know this, we've all probably had this experience on a website where you go and look for a product and you get a terrible result. Do you ever go back? Are you going to use that search engine again? I won't. So the most important answer you can deliver is that next question. So some questions that people are asking right now, using Lucene and solar. AT&T. If you Google right now, Redmonk, AT&T, probably solar, you'll turn up an interview that we did with one of the folks who built AT&T's website. So these guys actively use solar almost as we would term it as middleware. Right? They're using it for what they term essentially faceted search. So they are sort of dynamically constructing their website based on individual search returns. The guys from cnet are doing something very similar. They're doing essentially faceted search on many essentially on their product catalog and their portfolio. These guys, have any of you heard of these guys? Okay. What these guys are doing, I don't even frankly know what it is, and I had to write it down. They're doing comparative metagenomics. Do we have any biologists in the room? Anybody know what that is? Because frankly, I have no idea. But that's the point. The point of all of this is not just, hey, we can look up products out of a catalog and deliver those. The point is that this is the fastest way to get from point A to point B. And the only limitations that you have at this point with the current state of technology are the questions, are knowing what to ask. NASA uses this as part of their cloud. They use the solar components as part of their enterprise search. And the list goes on. Anybody hazard a guess as to what this is? How many of you have seen this before? No guesses. Anybody heard of InfoChimps? InfoChimps, I think we had a hand in the back. InfoChimps is essentially data marketplace. What they do is essentially make available for sale in some cases data sets. These data sets come from all over the place. They come from private institutions, they come from private individuals, or they come from governmental institutions. So what they do on the back end is that they put search to work. And they put search to work in terms of retrieving results. And what they do with these results is use algorithms to rank and score them. So what you're looking at here essentially is what they call, it's a calculated metric called trust rank. It's a calculated trust rank for InfoChimps itself on Twitter. And the point of this is that this is actually a product, right? This is a score. This is an actual metric that is calculated effectively entirely through search. So the point again here is that the ability to use search and the ability to make search important for your organization is limited pretty much just by your imagination. We need to move beyond the simple, okay, I'm going to look for something and find it. The next step is I'm going to look for something, find it, and decide, hey, I can actually use these results. I can use these results to produce something meaningful. And whether that's a Twitter metric or comparative metagenomics really isn't the point. The point is that you have the tools to deliver, a really differentiated experience these days just via search, by looking things up, putting the results to work, and deriving some value from them. So with that, I am done. Other questions that you guys have? So the question is there a practical upper bound on the amount? I think, I'm going to give you a typical analyst answer. I'm going to say it depends. And it depends almost entirely on context, right? So, clearly we have, examples, like a Google, right? Where, practically speaking, are there upper bounds on the volume of information that they can, index and return answers on? Not particularly. At least, not in any practical sense of that word. But conversely, how many organizations are Google, right, and have that kind of horsepower available to them? And the answer to that is very, very few, right? So, certainly there are practical bounds in terms of storage, retrieval, index speed, and so on. The interesting thing, however, and one of the things I explicitly did not want to sort of link into this talk because it's, frankly, a topic that's a little bit hyped at the moment is cloud. And, the cloud really does pretty fundamentally change what we can expect to deliver in practical terms. Where, we're at the point where, any individual can use a terabyte cluster, 10 machines, of reasonable horsepower, for a day for under $10. So the bounds of what's practical, from a data index search and retrieval perspective, are really going up quickly, and they're going up by the day. Simply because we have more frictionless and more economically efficient access to mechanisms, certainly than we did even a couple of years ago. Sure. The question is, do we get a sense of how much of the data is redundant or duplicated and so on? And the answer is quite a lot. Frankly, think of web analytics as just a simple example, right? When we put together our system, we're consuming data from Apache logs, web analytics tools like Google Analytics. We're consuming third-party data from people like Bactype, PostRank, and so on. And is there a lot of overlap and redundancy amongst this data? Yeah, absolutely. And that's just, certainly one example. When we certainly troll, when we're applying search, for example, to product catalogs, internal to companies, there's a lot of redundancy. Different versions, outdated versions, and so on. So that is a problem, right? And understanding in simple terms how to manage that redundancy and certainly compensate for it is a challenge. But yeah, there's a lot of redundant data. I don't have a figure for you if that's what you're looking for.
I don't think this is... Good morning. I'm listening to your opening part of the conversation. It actually reminded me, for those of us who were there, of what people were saying about relational databases back in the late 80s. It seems like every 10 to 20 years, a whole new infrastructure comes along that everyone builds on top of.
Yep.
If relational was supposed to be the organizing concept of data as it relates to itself, what do you see as the organizing concepts for this new generation going forward?
Great question. And I won't repeat it because we had the microphone, you all heard it. The simple answer is that I really honestly don't know that there is one. And, again, sort of as I was running through, earlier some of the different data database or data storage mechanism types, right? The commonality that they all have is that they're focused on a particular data type, right? So if we run through them, document databases are focused on documents, logically. Column databases are sort of a inverse of relational databases in that they're searching column down rather than by row. Key value databases are basically storing two values. Graph databases are particularly adept at traversing more complicated trees of information, right? So when we look at kind of the history of storage, we've come from file systems, where it's pretty basic. You put a file in a file system, you want to retrieve that, to hierarchical data stores, to, relational. And in between, certainly we've had attempts to augment, supplement, complement, the relational model, things like object-oriented databases. But really, it's only in the past, as I said, really 2 years that we've seen the explosion of different data types. And frankly, if there was a unifying concept, I would love to know, because it would make my job a hell of a lot simpler. When we're out talking to customers who are interested in this quote-unquote NoSQL thing, and as I said before, they're querying us on, how do I compare Hadoop to Redis? Well, one's a distributed, MapReduce engine, the other one's a essentially an in-memory key value store, right? They're not comparable. It's apples and oranges. So I don't know that there is sort of one grand unifying approach as we saw in the relational, world. I think, again, if they had a commonality, I think it's basically different tools for different jobs. And as a pragmatist at the core, I applaud that. I think it's a really pretty wonderful development. Now, that said, there are maybe 30 or 40 of those projects extant right now. At the end of the day, probably 5 or 6 will survive and move forward. But pertinent to this conference and pertinent to everybody in the room, Lucene and Solar, search isn't going anywhere. Search is one of those categories that is absolutely going to be viable, crucial, and important going forward. Because we've just seen too many organizations over the years try to get relational databases to do search for them, and it's just not fast enough. It doesn't do what they want. And so many of them have been writing their own search engines. We've actually helped a couple of our clients find people to write their own search engines. And, you just don't, there's no real practical reason to do that any longer, not with the open source tools we have available. Other questions? Right here in the front. Basically, if I understand the question correctly, we've had successive generations of persistence technologies. And, one of the common traits of these successive generations is that one didn't replace the other. Databases didn't replace file systems and many of the tools that we see today. I would very much agree, are not going to replace a relational database. If you're using a relational database, for example, as a back-end to an ERP or CRM system, are you going to rip that out and replace it with key value store or Hadoop or a Solar or Lucene? Absolutely not. There's no reason. A relational database is very, very good at what it does. It's an outstanding model. It's proven itself over time. It's a fantastic category of software. And it's a category of software that I'm sure, everybody in the room, relies on to some extent. So no, none of these tools, search included, is going to do away with, the relational database model. What is ending, in my opinion, and really none too soon, is the relational database is the solution to every problem. And that's unfortunately where we've been for too long. And I think that is over.
Are you concerned at all that privacy legislation will limit our ability to gather data?
Well, we're getting a little far afield from search, but I think that, I guess the shortest way I can answer that question is that I think we do have very, very substantial issues to work out with respect to privacy, right? So, focusing on search, for example, if I search and index Twitter, right? If I'm retrieving, through a variety of means, Twitter data, who owns that? Do I have the right to search and index that? If I'm if I publish a tweet, do I have any reasonable expectation of privacy? Do I have any reasonable expectation of copyright? Privacy is such a big topic. Honestly, we could stay here and talk about it for hours and hours and hours. But I think particularly with respect to search, the implications are, it's a challenge, because, basically, really as a technology firm or somebody involved in technology, the one thing that you want when you go and talk to lawyers, even if you don't like the answer, you want to get the same answer, right? You want to know that, okay, I can do this, I can't do this, so at least I kind of know the constraints that I'm operating under. And the challenge is today that when you go and talk to legal, I was at a conference last week that had a legal track, lawyers don't agree on, where and how and when some of these things apply. And just as problematically, laws, even in the most progressive countries are way, way behind. And so, yeah, the short answer is that, we do have pretty substantial challenges, I believe, from a privacy perspective. And navigating that kind of that legal maze is, it's going to be a hassle. I don't know, do we have time for other questions? 2 other questions. Awesome question. That's actually a really, really good question. So if you didn't hear it, the question was, how do I think data visualization and infographics and things of that nature will impact search? And my answer is that I think they'll have a profound impact, right? Because I think one of the real challenges that you see when you get involved in big data and you get involved in search and you get involved in sort of information retrieval is trying to make this meaningful, right? Trying to take graphs or trying to take information and put that into a graph such that an ordinary person can understand what you're talking about. And frankly, I think when we look at the industry right now, that side of the industry and that side of technology is way behind. If you look at really the infrastructure elements, we have most of the pieces that we need. I mean, yes, there's ample opportunity for improvement, lots of room left to grow, but really at the end of the day, there's still a long way to go. For the infographics and the visualization side of the house, because we're just not that good, at that right now. So no, I think it'll have a profound impact.
So some of you may know the famous story from the late David Foster Wallace, who talks about an old fish swimming in the river, and he meets two young fish, and he says to them, "How's the water?" And they look at him and they say, "What's water?" The one thing that has gotten very little discussion, because it's kind of like fish in water, is the open source thing. I think cloud is rapidly reaching that point. The question is, what are the mistakes that cloud can learn from the trajectory that open source took to get to its maturity?
Yep.
As we look at these two really important disruptors that have accelerated the implementation of these technologies and the value that they deliver. Where's the sort of look back and learn as opposed to don't repeat history?
Good question. I think actually I think there are indications that the cloud industry actually has already learned this lesson to some extent, right? Because one of the reasons, for example, in the sort of data space, for lack of a better term, when we think about search, relational databases, key value stores, all the sort of NoSQL properties we talked about today. One of the things that commercial data providers will tell you is that it is very difficult, if not impossible, to start a commercial entity in that space now with by being closed source. It's tremendously difficult to compete. And the question is, why is that? Right? Why is it so challenging to build a closed source alternative? Well, there's a lot of reasons. But the simplest one is that we've seen focus in the past on hey, do customers actually want to alter the source? Are they going to go in and modify the source code? So does open source actually matter to them? And I've always compared it to, it's like the right to vote, right? We have the right to vote in this country, and, pretty regularly, the number of people, the percentage of the population that votes is a little bit north of 50%. But if you try to take that right away from people, you'd have a very, very serious problem in your hands, right? So just because people choose not to exercise the right doesn't mean they don't want it. And, from an open source perspective, that is, in large part what is driving, the adoption of these systems broadly. And to bring it back to cloud, if we think about the platform as a service industry, right, which was initially characterized by vendors like Salesforce with Force.com, or Google with App Engine, or Microsoft with Azure, right? These systems have been substantially under-adopted relative to market competition from infrastructure providers. Infrastructure providers primarily being Amazon, which dominates that market at the current time. And the question is, why is that? Platforms offer a lot of benefits. You don't have to worry about scaling. You never have to worry about, hey, do I have enough machines? That's somebody else's problem. Well, as it turns out, if you're a developer, and actually just as much if you're an enterprise, you're a buyer, it matters. Because, if you go with, for example, Force.com, you're basically betting on somebody's proprietary standardized infrastructure, right? So Salesforce, which is behind Force.com, actually did sort of an interesting thing. December 8th of last year, they went out and acquired a provider called Heroku. And Heroku, if you're not familiar with it, essentially is a platform provider But it's a platform provider that is focused on a standardized application, or a standardized programming framework, rather, in Rails. They also added modules, right? So you could press a button and add memcache. You could press a button and add features. Now, these features were either open source or readily available third-party alternatives. So the important distinction being that if I deployed to Heroku, and I don't like Heroku for whatever the reason anymore. I don't like their uptime. They've raised prices on me. I had a fight with the sales guy, whatever. You don't have to deal with it anymore. You can go somewhere else. And you can replicate Rails, and you can replicate memcache, and you can replicate all these individual pieces. And that's a critical learning. So, what you've seen is VMware comes along with Cloud Foundry. What do? They released it, they first of all made it available as open source. It's a platform framework. And that platform framework is very, it's available under very liberal terms. If I want to take that somewhere else, great, I can. I can run it on top of a variety of pieces of infrastructure. Red Hat did the same thing in its recent announcement. So, basically to answer the question in a much more succinct form, what we've seen the cloud providers learn, over the past, year or two, has basically been that, pursuing a closed proprietary model is going to pose substantial challenges from an adoption perspective. Whereas mirroring, the open standardized approach that open source embodies is going to produce much better results from an adoption perspective. So, as I said, I think to some extent we've already seen the vendors learn that lesson. With that, I think we're out of time. Just as a logistical note, I'll be at the conference all day. Come talk to me. I would love to hear your stories about what you're doing with search. So thank you very much.